So, good afternoon. Thanks for coming. My name is Mandi. I am the Technical Community Manager here in the European region for Chef. The London office is where I work out of, but we also have some folks in Belfast and a couple guys in Berlin. If you'd like to get in touch with me at any time, I'm LNXCHK on Twitter. You can also follow me on Instagram. I'm way too old for Snapchat and any of those other weird things that the kids are doing these days. And Chef lives at chef.io. So I'm going to talk about the automation stuff that we've been working on for the past 10 years and the intersections it has with some of the DevOps stuff that's also gone on sort of in parallel. In 2012, I wrote a white paper for O'Reilly about building a DevOps culture back when DevOps was the new hotness and not all the boring stuff that everybody was already doing. So that's me. Chef, we're headquartered in Seattle. We have other offices around. There's about 270 to 300 of us on any given day. We've been in automation sort of as a business for about 10 years. So the company's been around through the entire modern automation lifecycle. The first product was Chef, which I'm going to touch on a little bit. It was a tool for automating infrastructure. You're probably, of all of our stuff, that's probably the one you're most familiar with. We're now working in security and compliance automation with a product called Inspec, which if you were in the test kitchen and testing talk earlier, was mentioned a little bit in there. And then we have a newer product called application automation for application automation, which called Habitat. That's probably the one that nobody's probably heard of. So I'm going to touch on all three of those and how we've sort of evolved, how we think about automation as things have sort of gotten crazier. So we work with a lot of big companies, and they have sort of this driving need to become better at software, right? And even folks who work in parts of the market that aren't necessarily thought of as software companies need to do a lot of software engineering to get the innovation and the good practices that they want out of the rest of their business. A couple of years ago, the then CIO of Alaska Airlines spoke at our conference. They're sort of our hometown heroes. They're our neighbors, right, in Seattle. And he basically, his story is, Alaska Airlines, we have airplanes, that's what we do, but at the same time, we're basically going to be a software company that buys airplanes. So a lot of their customer service and customer experience and some of these other innovative things that they're doing as far as keeping customers and growing their business have less to do with buying airplanes and more to do with innovating in the digital space. So mobile apps, and they were doing mobile tagging for bags and all kinds of other crazy things. So depending more and more on software, for folks who don't normally worry about that stuff, or they have software that was maybe built in the 60s and 70s in the case of how you build an airplane that is still running. So who ends up being a tech company? It's increasingly a core competency for pretty much everyone. We work with healthcare companies, we work with utilities, we work with banks and other financial services companies. It's hard to compete if you're still using the older outsourcing models, and we've seen that where, especially still in sort of slow-moving parts of the industry, that all the software work is done by a third party, and the project managers are really just contract managers, and it's still waterfall method. You write all the specs at the beginning of the contract, sign the contract, pay the bill, and off it goes and eventually comes back. And it's hard to be responsive. It's hard to speed up your processes when you're still working with that model. So we've been helping folks as they've been, some of them have been bringing back work, or they've been changing the way they do their contracting models. It's been super interesting. So we've worked through a lot of these projects with companies all over the market. GE has spoken at our conference a couple of times about the things that they've done. IHG Hotels, Bank Ampol-Lim, Facebook uses our stuff in a crazy, crazy way that no one should ever probably else use it. Just that's Facebook's thing, as well as other groups like SAP. So like all over the place as far as digital first, sort of web first, web native companies into all kinds of crazy financial services. So back in the beginning, and like this blog post, I think we've changed blogging platforms 2 or 3 times on our website, but we bring the old stuff along just for this post, basically, by John Willis. He was one of our first sales guys. And he wrote a post in 2010, feels like 3 lifetimes ago, what DevOps means to me. And this is where he first laid out what he called CAMs at the time, and Lean sort of jumped in a little bit later, but talking about the components of changing from sort of old school IT services to future-looking agile operations and what became DevOps. Talking about culture, automation, metrics, and sharing, and then adding Lean in when it became popular. And we focused in on the automation. We'd help people a bit with the culture stuff a little. Like our professional services team for a while was really just a bunch of IT therapists. If you can imagine, sort of they come in and you tell them your problems and they try and help you out. But mostly we're interested in automation, how people react to automation, how we can help them be better through automating processes. And as we talk to incredibly large groups especially, the feelings about automation and the visuals that people get in their heads about automation is that it's going to run amok and do something crazy, right? So, you've got the sorcerer's apprentice here, and he doesn't want to mop the floor, so he gives himself a bunch of mops and buckets to do it for him. And it just goes crazy, and bad things happen. And for a lot of folks, that's really how they end up thinking about automation. What happens if it goes wrong? What happens if it gets stuck in a loop, or whatever these horrible things are that they imagine? And we've tried to build our products to such a point that that's highly unlikely. Might still happen if you're intentional about it, but hopefully not by accident. But sort of bringing people out of the mindset that automation is scary and things are going to go wrong, and they can actually be part of the automation story. And that's part of the other vision we end up talking about with automation is, well, we're going to automate all this stuff and then nobody's going to have a job. And in some parts of the economy, I'm totally, yes, that ends up happening and will continue to happen as driverless cars and driverless trucks and things like that come on board. But what we've seen in IT, unfortunately, is that it never gets to that point, for good or bad, right? We've never worked with a team that said, we don't have enough work anymore for all these technical people, so we're gonna have to let them go. We end up with the 18 months of backlog that the team has that they can now address, whether it's improving monitoring systems, solidifying platforms, all these other things that they didn't get to work on because they were busy doing sort of manual processes all the time. And most of our customers are still hiring. Like, they're still bringing more and more people on board. And everyone you talk to is trying to hire. They're competing with every time Google opens an office in some city and everybody floods there. So we're not to the point where people are losing a lot of work to automation. They're losing work that shouldn't matter, shouldn't be the most important thing that they're working on. We're going to give them better stuff to do, hopefully, as the boring stuff gets automated. So we focus on 3 types of automation: infrastructure automation, security and compliance automation, application automation, mostly because they sort of flowed together in a pretty good life cycle over the past 10 years. So we're really helping people try to focus on stable foundations to innovate from, right? So we've always worked with sort of cloud platforms and some of that other stuff so that you can move fast and save money, hopefully, over time. So the things that we want from automation, right? We want to be able to go fast. And in most companies, we want to not break things. Like, we might break a few unimportant things as we're testing things out. But overall, we really don't want to be down. We don't want things to stop processing. We want to be very careful about breaking things. We also want to be able to scale. Like, if I'm going to launch some amazing feature and it hits and people love it, like, I want to be able to push that out there and not have people say, oh, well, they pushed this thing out and it was great for 5 minutes and then it went down. We also want to help people lower or manage costs as they can, do interesting work versus the same 5 strokes on the keyboard all the time. We want to be smart about the work that we're doing, make sure that it's impactful to the business. Over time, we hope to not get hacked, because that happens, right? It's pretty ugly out there. And we want to be able to run our stuff wherever we need to, right? And we used to tell this story in the sort of catastrophic failure scenario, where if something happened to your data center and it went down and you want to be able to pull all your stuff wherever you could get a CPU. And that's still an important story, but we're finding more and more places are really looking at multi-cloud solutions, multi-prem solutions, whether they're pushing things into their own data centers as well as out into the various cloud providers. All those kinds of things become more and more part of the story versus just the catastrophic loss that we were originally talking about. So that particular solution or that angle has changed significantly in the past couple of years, which has been super interesting. So we're helping people focus on the business, less on my job is only to press this button all day, and more about what I do has this effect for the end users. And this is tough, right? For a lot of folks that work in IT, the day-to-day work that you do, you have to sometimes do a bunch of mental gymnastics to figure out how exactly it impacts the bottom line. And what we hope is as we have these discussions with folks that we're automating the things that don't matter and giving you more time for the things that obviously do matter. So providing or prioritizing the tasks that have value for your users versus doing whatever is a shiny distraction or whatever you're used to or just the boring things that might be sitting there. And our users, our end users, regardless of what kind of business we're in, are expecting more and more businesses to be digitally savvy. And not just businesses, but schools and doctors and transportation services and all these things. You want to get on your phone, know when the next bus is coming, all that kind of stuff. So all those like government entities and whatever also need all of this customer service focused technical ability. So as we've started out focusing on infrastructure automation. Like I said, we started doing this about 10 years ago. So in the very earliest days of public cloud. And the focus is really on reliability, scalability, repeatability for computing infrastructure. And most of our customers at that time were digital first, web first kind of companies that they were not necessarily doing anything that wasn't technology focused. They were mostly online retail or social media or whatever. And as public cloud adoption got wider, this stuff got more and more important. This is really the earliest days of what we think of as being DevOps. And we went into it with command line tools. The previous generation had been a mix or maybe more towards being graphically oriented, which is hard to do when you've got 1,000 hosts and easier to do when there's only 12. And if you have 12 very expensive boxes that are doing your work for you, maybe it's okay to manage them with a graphic interface. But if you've got 1,200, 1,400 disposable units that you can just kind of like give up on and launch a new one in the cloud, dealing with that in a graphical user interface is less valuable. So our generation went straight in for command line tools, and over time, complex workflows built out of that. So the actual expectation of scale changed dramatically during this time. We had sort of the idea of vertically scaling components to sort of horizontally scaling components. Rather than putting more CPU and memory into one box, we're just going to launch more boxes. Then we have more services we need to manage. So between bare metal and VMs, there was a change in the way folks wanted to manage those things. Then we went to cloud, and now we're in containers, and who knows what's next, right? All kinds of crazy things. And we still have the same requirements for speed and efficiency. We don't want to launch the wrong thing. We don't want it to be broken when it runs. It still needs to be correct, even though we want it to be available quicker. And one of the earlier drivers for public cloud in sort of these traditional industries was that non-operations teams wanted access to the cloud. They're like, you're going to tell me it's going to take 6 weeks to get me another dev box. I'm going to put my credit card into the Amazon machine, cha-ching, and they're going to give me a box in half an hour or less. You have to justify to me why I need to wait for you. And the conversation has to start, well, yes, go ahead and use AWS. Here's the requirements. Here's what we want you to do. Here's how we're going to launch this for you, or whatever. And ended up being some very interesting discussions about managing that infrastructure and publishing what the components needed to be, what the configuration needed to be. And that led into our community really coming up with workflows based on source control, GitHub in particular, and how to push things around and save them, share them, all those kinds of things. We also want to mitigate any risks associated with repetitive tasks, and when all your documentation, all your scripts are actually wiki pages. You cut and paste, you miss a line, and you have no idea what happened. And we also want to ensure that all of our tasks are performed the same way over time. If I have a pod of 5 hosts and I want to add another host to it, it needs to match, right? So we also want to manage all of our environments. Back in a past life, when I was an assistant admin at America Online, one of the greatest costs we ever fought over was who's going to pay to run the dev and QA environments. And if you have a very large bureaucratic organization with chargebacks and financial accounting that way, it becomes part of the discussion. Who is actually supposed to pay for that stuff? And part of the wins for infrastructure automation is to start lowering the cost, the overall time components of managing more non-production environments. So we get cheaper dev and test environments. We're able to hopefully innovate more because we can put more stuff through them. We can build more of them for each team if we need to, and they can continue to build off of those. Over time, this lowers the risk of new features, right? Because the overall cost of the development there becomes lower, right? I haven't spent quite as much money if I had had to order 6 new boxes and wait 6 weeks and have them racked and have them networked and plugged into the switches and whatever else, versus I launched a couple boxes in Amazon. And I know they match because the ops guys gave me their recipes for them. And that was another part of it, making everything match production as much as possible. When we end up talking to developers and especially testers, for whatever reason, tests ended up at the bottom of the pile when it came to managing their environments. We want all of the environments to match production as much as possible. And a good way to do that is to use infrastructure automation, becomes infrastructure as code. Everyone uses the same code to develop their stuff. So here's how company X deploys Tomcat, here's how company Y deploys Nginx. Whatever the applications are that you're using, everybody has their own environment. They're all built the same. So infrastructure as code, this is sort of what it looks like. Tried to make it as readable as possible for folks who kind of know what's going on, right? So it's maybe not the most intuitive thing for regular software engineers, folks who aren't really up on how the operating system runs on a day-to-day basis. They don't really have to be, they can kind of guess. But especially for operations folks, it's pretty intuitive, right? If I want to deal with a package, I have a resource called package. I give it the name of the package I want to deal with. Maybe I give it a version. Maybe I tell it to install or uninstall or whatever. For things that are a little bit more complex, like users, if I want to add a local system user, I can add all the other components of that user's account right from my piece of infrastructure as code. I would eventually take all of these that I need and wrap them up into a shareable artifact. In our environment, we call those recipes and cookbooks. In other tools, they have other names. But we share them all as artifacts from a centralized location. You can check it into your GitHub repository. You can share it on our public repositories if it's okay to open source to the world, all those kinds of things. So that over time, you end up with a large library of all the things that you need. And they can be customizable, there's variables, all that good stuff. So that was great. It got folks to a really good place for managing basic infrastructure in the cloud environments that they were working in. So I think most of that's all repeat stuff there. So we integrated with on-prem stuff like VMware. We integrate with clouds, build up all these workflows. There was this huge explosion. Did anybody go to the CI/CD talk earlier? I had no idea there were like 50 CI/CD pipeline tools. I hadn't heard of half of them. It's crazy. All that stuff's out there. There's other tools now like Terraform. There's other build services, new deployment and orchestration services. And we want to be able to use our infrastructure automation to preserve all the infrastructure integrity, whatever we're doing on top of it. Even if I'm running containers, I want to make sure that I've got the right version of Docker on the system and has the right user accounts and is locked down the way I need it, whatever else I'm doing there. So as we were doing that, and we had our infrastructure as code, our community was full of a bunch of rabid Ruby developers. Ruby developers are a strange animal. And they like testing. I was just like, who met a developer who actually likes testing, but it's like one of their things, right? So our community was like, look, you're going to call this stuff infrastructure as code. We're going to stop you right there unless you also test it. And we're like, okay, fine. Like, what does that look like? And so over time, the community was like, all right, here you go. Here's some tools based on Ruby ecosystem tools, especially for testing infrastructure code. And there were a couple others even before this, some other earlier experiments that didn't quite pan out. And even Chef Spec sort of like slowly dying an open source death. But we're still using Rubocop pretty often. And then there was this other tool that was talked about in another talk earlier about called Test Kitchen. And Test Kitchen is amazing if you've never used it. Like, it's just flat out. It's a really excellent tool for managing my local environments on my laptop. So that I can boot up a virtual host, manage it well, and tell it, okay, hey, I want this to have Chef on it, and then I need Chef to install a web server. And oh, while you're at it, here's the code that goes in it. Oh, and I need these firewall rules I want to test out, whatever else you need on it. So testing gave us this advantage, right, to sort of test the intent of our infrastructure code. And gives us this, again, solid foundation for whatever future work. And it also gave teams a good place to start for migration testing. If you needed to go from CentOS 5 to CentOS 6, you plug in your tests first and then see how things went with your code. It really helped us do a couple big version upgrades with some customers. But it's also a new way of thinking about what's going on in our systems, right? We're like, okay, I'm going to install a web server here. What does it mean for that to be successful? And then you can also apply that thinking to your monitoring, right? Because sometimes people are monitoring everything. Sometimes they're monitoring nothing. And you're like, all right, what does it mean for this service to be correct? I can actually put that in my infrastructure code. And before I even check anything in, I can test it in Test Kitchen and know that I'm right. So as that evolved, we also started talking more to larger parts of these organizations. And the security and compliance folks were like, you're doing a lot of stuff with this automation thing. How do you know it's safe? And we're like, well, we've got this testing thing for you. And they're like, I don't know if that's enough. I'm not sure it matches what we're thinking about, especially compliance folks. If you've worked through a compliance audit for PCI or whatever, like those folks run around with paper. And binders, you didn't even know they could make binders that wide. And they check the things off in their checkboxes. Sometimes they do it in the data center and everybody's in a coat and it's freezing and you're like, why are we doing this? But they speak one language, right? They've got a PDF file, it has a bunch of checkboxes in it. That's how they're going to work through your audit. And then maybe you've got an on-site security team and they are working with your upstream vendors. They've got shell scripts that they want you to run and test things. They've got kernel modules or other patches or whatever it is that they're working on, CVEs, and they're talking to CERT and all this nonsense, right? It's like, all right, well, they speak that language. It's totally unrelated to the compliance people. And then our day-to-day operations folks, they're now speaking infrastructure as code, and they're like, well, you know, I can put this all in Ruby or whatever and make it all happen. And we saw an opportunity there to sort of bring all these folks together. So it was mentioned earlier, InSpec is our, and this is all the open source components of it. InSpec is our human-readable, machine-readable solution for helping you integrate all these security and compliance requirements into your infrastructure as code pipeline, into your continuous delivery, and all these other automated processes that you now have. Teams can encode their requirements, build profiles just like you would with infrastructure as code, run your tests on a regular basis, run them locally, run them remotely, run them as a job, whatever. And what we're hoping for is that we can help people prevent their yearly or biannual audits from being a big, onerous, painful process. So you get regular insight into the overall health of all your security and compliance, whatever you've encoded into it. So it's less like intrusion detection and more like the preventative testing tool. And then last year we added some stuff to test for cloud infrastructure. So if you're giving your software engineers the ability to launch their own hosts in the cloud, you can run the InSpec tests against your infrastructure in the cloud on a regular basis and say, look, this AMI is in violation. We need you to either update it or relaunch or whatever you want to measure there. You can make sure that the permissions are set correctly on an S3 bucket so that your student data or whatever else doesn't get out there on the web like some folks have had happen. So we test our infrastructure regularly. We've got things like testing a package, and if we want it to be installed, if we want to test the version, we test our user, we want it to exist, want to make sure that its shell is set in a safe way, these kinds of things that match completely back into our infrastructure as code. So we can get sort of one-to-one testing. As we're building things, we can test our intent, make sure that by the time they get deployed, they're all correct. We can also collect all these rules into profiles that we then share. We can organize them by frameworks, say you're following the CIS standards or DSTIGs or some other things, or by your application. This is our Tomcat security profile. Each profile can be created of multiple test files, so you check it into your software control management just as you would anything else, and your compliance teams can view it, make changes, pull requests, whatever methods you're going to use there. Your security team can add stuff to it, and your regular operations day-to-day folks can add stuff to it. So you can really start to get everyone's expertise involved in that. You can pick and choose certain tests out of a community profile, because some of them have thousands of tests in them. You can ignore things. There's a whole bunch of them at dev-sec.io, which is one of our teams and some open source community members publish stuff there. And you've looked at some of these large commercial profiles. If you implement everything on them, your host is so secure it doesn't talk to the network. That's usually not what people want. So you can share them around and hopefully lower the amount of time you spend in security review. Because when you're trying to go fast, you don't want to get up to the end to security review and security goes, oh no, you can't launch that because it doesn't meet the requirements. So there's how they match up. And as we were finding over time with a bunch of the stuff that we were working on, there you get a lot of what we call platform complexities. And we started thinking about what's next, what happens next. So before we do that, let's do a quick, just give you a view of what Test Kitchen and Inspec looks like. So what I have here is one test box, and it is, in this case, CentOS 7.2. I'm using Vagrant rather than other things that could be used like Docker or whatever. You can also deploy these to cloud if you want to. I'm provisioning with Chef, which means I'm going to converge a Chef run while it builds the box for me. Then I have my choice of verifiers. Inspec is included here. If you're using, say, Puppet, there are testers available on that side as well. Ansible, the things are sort of there, but there's a couple other protocols that the Ansible folks are using that don't plug in as nice. And I have the ability to run some tests. I'm going to build the box, make some changes that I need to, and then I'm going to pull in one of these massive profiles right from the internet, from my GitHub, right? So as my security and compliance folks are working on these profiles, I don't necessarily need to know anything about how to find them or download them. I don't have to keep a local copy. I can just reference whatever they've last published and bring down the latest versions. And sometimes that goes really well when I do these demos, and sometimes they haven't caught up right. It does little weird things, but we'll see how it goes. So the first thing I'm going to do, the box is already running, and I'm going to just run a verify, and that's going to go through and run this baseline so you can kind of see all the stuff that's in it. And then I'm going to run the companion package that is supposed to harden against this profile, and we'll see how many tests pass. So I don't actually have to log into this box. I refer to it via the kitchen commands. We'll just let that do what it does. Okay. So it's a pretty large profile. There's all kinds of stuff in here about networking best practices, file system settings. And you can see they're kind of organized in a couple of pieces, right? So there's operating system level things, and it's more of a description and indexing tool. So if you were doing, say, CIS, you could actually put the rules in based on the CIS guidelines, so your auditor would know you're following each component correctly. So we've got a lot of failures. A lot of red. We don't like red code, that's not good. So I'm going to go ahead and I'm going to uncomment the companion to this. And these are both available on dev-sec.io, so you can take a look at them and see the kind of things that are in them. And most of the time, this thing will go through and clean everything up. We'll see. Last week it left one hanging, so we'll see how that goes. So I'm going to tell it, rerun the infrastructure as code part with a kitchen converge. And it's just going to do a chef run with the new cookbook included. Oh, and it didn't work this time. Ah, demos. Oh. Yeah, there we go. Try it now. Okay. So it's fixing the things that need to be fixed. And then we'll rerun our verify and see how it goes. Close. So it's still one that hasn't been fixed. So I'm pulling these down real time. I'm not using local caches. They're pulling in from the wild internet. So as the teams are working on these, sometimes they get out of sync. It's fine. But it goes through and fixes a lot of the stuff that is in here. I can choose if I want to now. I can ignore this one, package 08, if I don't want it to error in my workflow until it gets fixed or whatever. So for right now, we'll just ignore it and move on. So that's Test Kitchen. Super helpful for sort of that local fast response as I'm working on my infrastructure code. Also helpful for, especially with the inspect stuff, when you're doing new features, adding new components to an existing system to know that you're still meeting all of the security guidelines, whether it's settings for ports, settings for services, nobody's setting up NFS without you knowing about it, that kind of thing. So as we were working through all of that, we're like, all right, well, folks are moving into containers. Everybody asks us, what's Shift going to do in container land and blah, blah, blah. And we've experimented a couple of times. We had some things with Docker a few years ago, and it was like not quite the right fit for what the workflow ended up being. So we kind of stepped back and said, all right, well, what's the important part of what you're doing on the computer there? There's a lot of knowledge and stuff that goes into how you get code onto the computer, but the important part ends up being the application that you're eventually going to install on it. So Habitat is sort of our experiment in what we want the central components to look like for an application. And we're sort of after that 12-factor app Valhalla, whatever you call it, the idealized 12-factor application. So looking for the important things that your application needs, its dependencies, not worrying about all the other stuff that's on the operating system, looking at the container space and seeing that like a lot of the containers people are using are really just small VMs. There's a lot of junk in there that doesn't need to be in there. And then you need to worry about over your life cycle, well, what happens if one of those things has a bug in it or whatever. So toss all of that and think about what I actually need for my application to run. is a lot of times not really that much, right? If you start above the kernel and you're in like from glibc up, like that spike through the operating system, you're not going wide, right? You're not installing everything. You're just going to install the things that go straight down through to the kernel for the application that you want. So Habitat produces a self-executable artifact. You can also run it, you can export it to a Docker container. It ends up being pretty small. A couple other platforms and things like that. And it includes all of your dependencies in a platform-agnostic way. And for folks who are Linux sysadmins and have worked in Debian-derived environments and Red Hat-derived environments, you know that if you want to install a package, you need to know that in one land, the libraries are -dev, and in the other land, the libraries are -lib. And that's bad enough. But if you want the newest version of anything in Python, well, in this world, they're also the tools, so it's really hard to manage all of your Python stuff, and it ends up being a big mess. So you don't want to worry about any of that stuff anymore. I want the exact things that my software engineers need. I want that to come as part of my artifact. And that's what we're trying to do with Habitat. So it starts out, you do your code, you push it into whatever your origins are, your GitHub repository, or other components. And if you want to plug it into our public build system, you can do that, or you can build it locally on your machines. Run it wherever you need it to go, whether it's just regular VMs in the cloud, or if you're using Docker or Kubernetes or whatever, launch it there. And if you're not into a place where you're running a lot of container orchestration yet, you can actually make use of the included supervisor that has its own protocols and can do its own ring organization and things like that for you. So it has all three of the steps built in one single artifact. So there's no extra components necessary. So it ends up being a really different approach, so you get that spike, right, through the operating system. You're building your apps in what is basically a clean room. We call it a studio. It's a busy box, right? So very, very tiny Linux VM, implemented as a Docker container, I think, on most platforms now. And you package all your dependencies. You end up with no undocumented requirements, so that like somebody had too much access on the dev box, and then when it gets to QA, there's like, well, where's this library you think you need? You didn't tell us we needed to install it. We want to not have that happen. We create this artifact you can truly run anywhere, and we can manage with this native supervisor if we want to. In addition, we built a service, so it's a SaaS platform, allows you to attach, right now it's just GitHub, repository to the build service, which is run by us, and you can publish native artifacts or publish directly to Docker Hub. Other infrastructure or other integrations are coming later. So you check in and change, build the artifact, and can actually then update the running environment, and you can update configuration components as well. So I have a bit of an example with that, and this is a Tomcat-based application. And a couple things to remember. In Habitat land, every build has a unique ID. So there's none of this, and I don't know if this is only Java guys who used to do this, but they'd publish through a fix without changing the build number. So bad. So every build has a unique ID. It's a timestamp down to the seconds. Every build creates its own immutable artifact if it succeeds. And then you can actually export config, so you can change all the things that you need. And these are encoded in TOML, because most of our stuff's in YAML, and we decided we needed another markup language, right? Why not? So these things are in TOML. It's a little bit easier to read from YAML, but it all looks the same to me. I can't tell. Just like, oh, brackets and dashes, whatever. So what this thing is two hosts, and they're both in the cloud. And host 1 is Ubuntu. Why not? And host 2 is CentOS. And I'm going to fire up the Habitat supervisor. And this is just a management process that runs as a service. And then the supervisors will be hooked together. So they'll be peers. If I had a lot of these, they'd form their own mesh, right? They have a gossip protocol, they chat to each other, they do leader elections, all this amazing stuff happens in the background, regardless of what kind of applications you're running. So if you're running something like Redis that already has its own sort of leader-follower configurations, it can also make use of those protocols. It can sort of piggyback on them. But I'm going to run stuff that doesn't know anything about that, and they're just going to use this as a shortcut. So I'll have two supervisors. On the Ubuntu box, I'm going to fire up a MongoDB database. And then on both of them, I'm going to run a Tomcat application that is going to show the national parks in the United States. So let's see how this goes. So let's close this one. And here's my first one. So I've launched these a couple times, so there's some stuff stuck in the queue. But the interesting part here, I'm running hab subrun. So this is a bear supervisor. It's loading up onto the network, and it has a couple things it's doing. So they talk to each other on one port. It has an API gateway that I can tell it things on another port. And then it has an HTTP gateway on another port, so that if I wanted to go and look at something on these applications, I can actually do that. So I think I have one of them fired up here. So they publish JSON information. Oh, maybe I don't have it running yet. Okay, and then, so that's one. So this is the second one. This is a CentOS box. And I'm going to tell it, hey, go find that other one and create a pair. They're going to be peers. If I want to add a third one in later, I can tell it to attach to either of the existing ones. It doesn't matter. So I'm going to tell it, hey, go find this other one. I'm using the internal IP addresses, so this isn't going out on the internet. It's all staying internal to the cloud network. And it's going to do the same thing, loading up its various protocols. So now I have these two boxes, and they both have the supervisor on it, and the supervisors are attached together. So now I should have some info here. Maybe. Okay. So here I can tell, so I'm talking to one of them. I get the stamps of the IDs for both of them. So here where I have supervisor member ID, so this is just a new unique identifier on the ring. And I can see that they're connected, what their IPs are, the kinds of things that are going on in the ring right now. Okay. So now I'm going to make it a little bit more complex, and I'm going to tell each of these boxes, I'm going to start up the MongoDB on this box. So this is going to take the code that it needs off the internet, and I'll show you where that's held, and launch my MongoDB. So hopefully it'll go there. Okay, so that'll run. So all this stuff comes down from habitat.sh and what we call Builder. And you can search packages on Builder. There's a lot of stuff that's out there already. The project itself is about 2 years old, so there's a lot of stuff that's already been open sourced, things that have been contributed and are managed by us, things that are contributed by the community. There's a bunch of stuff under core that is sort of the main things that we manage and provide, but then we also have this chef demo packages, that's where this stuff lives. So I loaded up np MongoDB, and this is what the package looks like sort of in storage, right? So this not running here, this is just the metadata about it, and behind this service is the repository that holds the artifact. So I get information about when was the latest stable one built. I might have things that live in unstable for a time, and I can launch those optionally. By default, I'm going to launch whatever is most recent stable. You can see there's a checksum. Here's my release timestamp, so it's very hard to get repeated release numbers, almost impossible. And a bunch of information about what's actually included in the package, right? So this is MongoDB. I have some metadata about it, and it exports a port if I wanted to change that, stuff like that. So right now there's, I forget how many thousands of packages are currently included in Builder, but you can pull in all kinds of dependencies for, in this case we're using Tomcat, so you're going to pull in like Java stuff. And if you're using Node, there's a bunch of places that you can pull in things for Node and that kind of thing. So now we'll fire up the Tomcat ones. find my Tomcat. And I'm going to tell my National Parks application. So it has in it all my things that would be in my WAR file, right? So all the Java stuff, plus the Tomcat layer, so the container servers there, and the library to talk to MongoDB, and the Java components, all that stuff, and anything that those things depend on, all come in this package. So we only need this one thing, and it's going to pull in those things. I have to tell it where the database lives. And here, it's going to ask the supervisor. So it's basically going to talk to the ring and say, hey, ring, where is database np mongodb.default? And that's the service name that I launched earlier. I can launch services under different names if I want to do dev, QA, prod, whatever. In this case, I just have default. So we'll fire one up here. And we'll watch that go. Looks like a Tomcat startup. And then we'll launch one over here. And I don't have to give it a different thing. So I don't have to tell it, connect to this IP address, MongoDB, because it's going to ask the supervisor. Because the supervisors are already talking, it knows where this resource is. It starts starting up there. Okay. So if all went well, I should have applications on both of these. Okay, there's one. There's the other. So both of these components are now talking to the same MongoDB database. And they are, one's running on Ubuntu, one's running on CentOS, running the same commands, they pull down the same artifact. That's all they need to do. So I can put this thing wherever I need it to go, which is super helpful. Then I can look at the actual services information on the supervisor, and it tells me a whole bunch of things. So I've got my np MongoDB, I've got information about my other components, and I can actually query the lower packages that I've included. So all of my dependencies that I've brought in my artifact, things like if I need to check all of my running instances for a bad version of Linux headers, or I need to do an update to those, I can actually query these interfaces and say, all right, I know that these instances need to be updated and rebuilt based on this particular error. So there's a lot of information that ends up being published in the supervisor there. So I know that's kind of like a shouty, oh my gosh, there's so much stuff going on there. Fortunately, there's a couple of really awesome tutorials on our website about Habitat, and those are super helpful. So let's see if we can get this back. Oh, there it goes. All right, okay. So that's what we put together. 5 commands, basically, to get them to go. So that's it. Thank you. For more information, you can find us. Our main website is chef.io. InSpec has a bunch of stuff on their website, as well as dev-sec.io. And then all the Habitat stuff, including the Habitat website and all the documentation, all that stuff, is on habitat.sh. We are at Chef on Twitter. We're in Slack. We've got all kinds of tutorials that are basically like try it yourself in a terminal kinds of things that you can do online at learn.chef.io. And we'll have our own community summit in London in October. So thank you for coming. I have some stickers left if anyone needs stickers.
Any questions?
Do I think it fully, you mean is it a fully implementation sort of like a solution or replacement? Probably not. It's an interesting plugin, I think for folks who are already sort of proficient with Docker. It might be something interesting to look at for how you build your containers to sort of manage them over time. And one of the other things that I don't have a good demo for yet is taking older like COTS applications and putting them into one of these Habitat artifacts and using that as the transport to get them into the cloud. We're working on some white papers about that. So later in the year, we'll have a better story. But we're seeing a lot more success doing that than sort of the traditional folks that are already sort of hip to the Docker jive or whatever. So that'll be another interesting thing to use it for in the future that way. Otherwise, it probably plugs into most of the other Docker ecosystem as it explodes into. It has a lot of that stuff. Yeah, absolutely. And you can actually just use it to export your containers and use it as a build service just for that. So, thank you
Thank you very much.
for your time.
Yeah. Applause, please.